Okay, so basically, this is the second section. We are going to understand the data uh, by writing short programs, and through that programs we will show the numbers about the data. That number will give you the idea that understand the data, how we can understand the data through stats, through those numbers, huh? And then in the second, we will try to understand that data through some visual things, okay? So that's why it is first with the statistics, and here looking at the raw data. So we have a file, we have a raw data set, you can say. And if you want to see uh, the rows are columns of the data. I'm not saying how many number of rows and how many columns in your data. No. If you want to display the data in rows and columns, then how you can do that? Through your Python or pandas data frame, so that you already have installed along with the Python by taking instructions from those MS Word files. So for this, if you want to see what is your data, you have to install this pandas library. And in this library, head function is available. Now we are going to apply that head function on this database, PIMA Indian data diabetes dataset. So this is, you can say, this is our file. This is our dataset, which we want to display. And for that, you have to import some. So you have to consider this pandas data frame. From pandas, we are importing what? We are importing read.csv file. This is a module through which you can, this is a function you can say, or module, through which by using this module, you will read the files, CSV files. And then here, path is equal to R for read only. And then in the double quotes, you are giving the path to the data set where it is available on your computer. Header names means column names. So header name is equal to in the data set. I showed you this PIMA, or let's see. I showed you, I think, this database. Let's have a look on this database. Yeah. This is the PIMA Indian diabetes dataset. Have a look on that. This is the actual CSV file. So I will, when it will open, we will see. And this file has 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Huh? This file, this Excel file, which is being opened, this has 9 columns. As you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there is no column names or headings for that. So we will, so we are giving headings to these columns, okay, here. So you can give any names by your own. So first is for pregnancy, then plasma, blood pressure, skin, or something like that. So we are giving these headings as a list, because when they did this, where is my pen? No. So this symbol is a symbol for the list, you know that. And then here we are reading, we are using this module, which is available in this pandas library. So read CSV. We are giving, you have to give the path of the file which you want to read. And then names is equal header names. And here it is, we are considering the column names. Header names is the same thing. And names is normally the word in which we are going to store all these names. It will read it will read that Excel file completely. It will read that Pima Indian Excel file completely with all rows and columns, huh? And it will store that file here in this data object. And now we are printing what, how we can print data, and then we are using that head function, which will display the rows from that Excel file. So data dot head. So this is, you can say in object oriented, this is an object, and then you are calling some member function, a method. Head into 5 means that you have to display 5 rows. Okay. So when you will do that, it will first display the headings and then first row, second, third, fourth, and fifth. Okay, from 0 to 4. And this is that data which is being displayed from that Excel file. And if you will copy this code in your IDE, you can run it easily. But the only one condition, you must have this file with you. Okay. Now, checking dimensions of data. Here, dimensions mean the number of rows and the number of columns in your data set. In your data set. How many rows and columns of data sets are available? That is called dimension. And how you can check it and why you need it. Because if we have too many rows or columns, then we can understand that it will take too much time in computation. And if the number of rows and columns are not too much, then we can say that we don't have much data. So we want to know, if you have collected some data, you want to know that how many number of rows and columns are there. Okay. So the reason is that if you have too much, then you can understand, oh, it will take too much time, huh? If it is too short, then you can say this is not enough data for my experiment or for my final project. How you can do that? Okay, from pandas, okay, that is the same thing. Import read CSV, and then path read only, and then we are considering now another data set, which is iris CSV. And then read CSV, and you are giving path into it. So you can give path here in the previous file. You are giving path and the names. Okay. And here we are not giving names. We are giving only the path. Okay. Because names may be there or maybe not, but we don't need them. So read CSV path, and we are reading that file, putting it into the data, and we are simply printing print data.shape. So you can use this module of shape for this object. And it will give you what? It is giving a dimension, the number of rows and the column. So 150 is the number of rows, and 4 is the number of columns in what? In this data set. And I can show you that data set iris, which is about flowers, I think. Yeah, sepal length, width, petal, headings are there, and you have these. So 151 and 4 columns, huh? One row is for the headers, so 150. So 150 rows, 4 columns. Okay. And here I'm not displaying any kind of diagram in the output, because the topic is understanding data through stats, through numbers. Okay. So these are the numbers, and we are trying to understand the data from these things. And you know why we need to find the dimension of the data. I have given these 2 reasons, and then here you can do that. And then getting each attribute's data type. We want to know the data type of each column, each attribute, each feature. I can use different words, okay? I want to know the data type of each column, or each feature, or each attribute. These are the 3 different names. If you will know the data type, only then you can process something with that, okay? So then how you can do that? Sometime you want to convert one data type into another. So then you must know the data type of your data set, huh? So that's why, okay, how you can do that. So these are the same thing. I will not repeat. But now my data set is iris.csv. So this is the same thing. And here I'm printing what? Data, that object, and then dot d types, which mean data types. But this d type is a reserved word. You have to use it as it is, okay? Because you are calling a method for this object. So then you can understand that here you cannot write something by your own. So this data can be a different variable. You can use some different variable here, and then you can use the same variable here. But this d type fixed, reserved word. So d type, and if you will run this code, it will give you the output which is given on the right hand side here. This is not the output, okay? There would be some students who will give me the answer like that, RHS, huh? Without thinking. So the output is on the right hand side. So here it is right hand side. It is giving me that there is a column which has the name sample width and it has the data type float 64. Float. You can remove 64. Sample width float, petal width float, pedal width float, and D type is what? It is an object. So this is, so here you are again playing with the numbers. If you want to know the attribute of the data type, you can do something like that. And if you want to show a summary of the data, statistical summary of the data, which means a summary of the data which is displaying only numbers, huh? And we can see the summary of the data for different purposes. It can be different purpose. And in the pandas, what function is available to see the summary of the data? Describe. This is available, describe. And it gives you what? It gives you 8 different things. Number one, it will give you count. Count of rows in that single column, okay? You will give the column in one single column. How many rows are there? You can understand there would be some cells which are empty, some not. Maybe one column has 20 rows, other column has 40 rows. It can happen. So count of rows in that column and then mean. In that one column, it will count the mean of the values which are available in that column. It will count the mean. It will count the mean in that value. Just want to see what values. What you are doing. I did. No, I don't believe it. Because that screen is there, so why you are seeing there? So mean. So for example, here you have these. So mean will do what? It will give you the mean value of this column, huh? One column. And standard deviation. Standard deviation of the values in that column. Mean is different thing. Standard deviation is different thing, depending on mean. It has a different formula, okay? It has, maybe you have seen sigma is equal to xi minus mu divided by n under root. That is standard deviation, huh? Spread of the. Yeah. So it will give you what? It will give you the standard deviation of one column, okay? One column. You will have the values. Mean is different thing. Standard deviation is different thing. Maximum, minimum value in that column. In that one column, minimum, maximum, 25% of all the values in that column. What is the 25%? What is the 75% of all the values in that column? And what is the median? 50% of the values in that column. Okay. Let's see the source code. So it is red, which means you have to do it by yourself. Okay. This is for me, huh? This is an indication for me. But have a look on it. So this is the same import read CSV. And then from pandas, we are importing another thing, which is set option. Another library, set option. This set option is a function to make our output beautiful. Okay. To make our this output. Okay. This output. This set option has to set the decimal. For example, after this point, we will fix that it will go only up to 2 digits, huh? So these kinds of thing, huh? These kinds of thing is available in that set option. But this is not my objective to explain it, okay? And then path, read only file. We are again considering PIMA, Indian diabetes, names. These you understand. These are the same thing. Column headings, data, and then we are reading the file, this data set with the header names and storing it in data. And then set option, and we are saying the display width, this width, okay, the display width would be 100. And then set option, we are saying precision would be 2 digits. Precision is something I already said. This point and then 2 digits. This is the precision. And then we are printing here. Print data dot shape. This shape we already know. This shape is about number of rows and number of columns. This shape you have seen here about number of rows and number of columns. And then actually this is the last line. Print data dot describe. So this data is that data which is containing object which is containing the address to the whole data of the file. And data dot describe here, this is fixed method we are calling. This describe, this print statement, this print data dot shape is printing only this thing. That's 768 rows and 9 columns in this data set. And print data dot describe is basically giving you this whole stuff. It is mentioning all the columns here, and then count of that column is count of rows 178 168. So these rows, it is up to here, you can see 68. And similarly for this column, this is the count. For this column, this is the count. This column, this is the count. This column, you can see, go on, like that. What is the mean of this column? Pregnancy. This is the mean value. For this column, this is the mean value. For this column, this mean value. Mean value, you can understand mean value of all these values, For example, what is the mean value for this column? Then what is the mean value for this column? Separately, And then standard deviation of this all is mentioned. Minimum value, 25% of this column. 25% of this column is 99. 50%, 75%, and the maximum value in that column. This is easy, This is easy. You only have to practice or memorize this function. That only from this function you can get all that report, Now, reviewing class distribution. How in your data set, how the classes are distributed. Class mean categories. You have studied in supervised learning classification, And you can see how from the data set, male is one category, not spam mail and not spam email. You have seen some example, something like that. Next time, all the students will try to sit here, okay, or in front of my vision. Now you are behind these screens. I am not seeing you, okay. I'm not seeing you. And you are sitting there by your own intentions and by your own will because you want to remain hide and you want to do something else. Okay. I can understand. Okay. I'm not a foolish person. You can consider me a foolish person. Okay, then I'm a foolish. But I'm not. Okay. I can understand. I'm understanding with the why you are sitting there. This is not my loss. Okay. This is your loss. So that's why I'm advising you not to do that. If you will come in the last 10 minutes, I will put your attendance. Okay. So then it is better to sit outside, do your work, and don't disturb the environment of the class. And in the last 10 minutes, you can come and you will have your attendance. That is easy. More easy than this situation, huh? Anyhow, reviewing class distribution. So in your data set, if there is some data related to classes and you want to see how your classes are distributed, then what you have to do and why you want to see this class distribution, because you want to detect that if there any imbalanced class distribution. I don't want to claim this thing, okay. I don't want to claim this thing because I don't want to make my Allah Almighty angry, okay. But I am uh, I don't know. Nobody will teach you something machine learning with the source code, okay. This is what I want to say. People will teach you machine learning theoretically, but here I am teaching you with the source code. So if somebody want to learn, then I think it's a good opportunity for them. But if not, then okay, what I can do? I'm a poor old man. I cannot do anything. I can only advise like a father, huh? like like this, huh? So anyhow, why we want to review the class distribution? Because if you have a new data set, you don't know the classes that the classes are balanced or not balanced, or your data is balanced or not balanced. So if you have highly imbalanced class distribution, then you want to see what is the distribution of the classes in the data set. You want that because imbalanced classes is an issue. It will not give you proper results. And you want to handle that during this data set preparation. Huh? This is the process. This is the point of data preparation. How you can do that? Okay, these things same. Pymandian hypothesis, headers. Here we are reading that file. And then here, count hyphen class. This is a variable, don't worry. Okay, you can put your own variable. Is equal to data. Data is this. You can say this object that you have created for this whole data set. Data dot group by and the class is the header name, is the header, is the column heading in your database. Okay, the last column in the this is the Pymandian data set, and in this is the last column in which you have 0 1 0 and 1. 0 for one class, 1 is for another class. 0 is for one class. So in this data set you have two classes. So you are saying that whatever the data you have there, in that data, sort them according to this class, and their size. What is the size of that class? You will count. It will count what? it will count all the rows with zeros. Maybe it is 250 rows, huh? And then it will count all the rows, all these rows with ones. Maybe it is 300, huh? That is the size, okay? That is the size. So it will sort the data. It will what? It will count, or you can say it will sort the class with the size, zeros and ones, and it will store the count here in this variable which you are printing here. So if you will print, it will give you what? The class, this is the heading, and then class 0 has size 500, yeah, count, and class 1 has size 268. And one class has 268 entries, other has 500. Imbalanced data. Imbalanced data. Maybe one has 250, other has 270 or 75. It's okay. Okay. But from this data, now you can understand that this is what the second, this class is almost the double the size of that other one. And then what will happen? It will affect your results also. Sorry for this again, because now this is happening with all the people, huh? Something is wrong with the throat, huh? D type. So data type is what? What is the data type of this class? So integer. But from this value, you can understand that classes are highly imbalanced. Are highly imbalanced. Okay. Reviewing correlation between attributes. What is the meaning of the attribute? What is the meaning of attribute? Last one. What is the meaning of this attribute? Yes. What is the meaning of attribute? Boss, nice boss.
Attributes
Yeah.
is the main primary thing. And I don't know how to describe it, but it's something important in the same line.
Amber, what is this attribute?
That's very close.
You want to tell, huh? What is the attribute?
The feature, the label.
The label. What kind of label? Feature. You said feature. What is feature?
The feature.
In easy words, so that we all can understand.
We have a data on the, for example, in the house. So number of room. That's kind of the feature.
Good. You are right now. So the column heading is called the attribute, okay? Or the feature. So that's why I normally use different words. Column heading is the most easiest word to give you the meaning of attribute or feature, okay? So reviewing correlation between attributes. So now we want to see that between the columns, is there any relation? Okay. Is there any relation between the different columns of the data set? So review, we want to review, we want to view, huh? We want to look into it. And if you want to find the correlation between the attributes, now you must have to understand what means attributes. Then there is the most common method is Pearson correlation coefficient method. Pearson correlation coefficient method. And it has what values? If the coefficient, it will calculate the value for this coefficient. And if that coefficient will have one value, what it means? It means fully positive correlation between the variables. Variable is another name for the attribute, for the feature, huh? Because variable can take values. So variables, attributes, features, column headings, same meaning. So if the value is 1, it means that there is a positive correlation between the variables. If the value is -1, it means that negative correlation between the variables. If the value is 0, it means no correlation between the variables, between the two columns or two features or attributes. And there are some algorithms like linear regression and logistic regression. And if you have a high correlated attributes, if in the data set your columns are high correlated, which means positively correlated with each other, then these algorithms will perform what? Poorly. So now if you are going with some machine learning model, and if that learning model is with the logistic regression, which is also a neural network, okay, which is the basic foundation of neural network, then if your data set is correlated with this value, then you must have to look over it. You have to do something with your data. So you have to remove this correlation, okay? So that's why we have to review one column with other column, one column with one sec. So if you have 5 columns, then you have to see one with the second, one with the third, one with the fourth, one with the fifth, two with the. So you have to check all the combinations. You have to check. You have to check all the pairwise combinations for the correlations of the attributes. In our data set, you have to make all these possible pairs, and then you have to check that correlation is existing between them or not. And if it is existing, if correlation is the need of your model, then okay. If positive correlation is not the need of your model, then you can remove it. The techniques are available. You will see them. Now, sir.
About the last part, yeah. The linear regression, I think it basically gives the correlation. We said here if we have highly correlated attributes, it perform poorly. For example,
Yeah, normally on linear regression, you have one dependent, independent or dependent variables, or you can say two variables, and one is linked with the other. One is linked with the other, and in this way, data will go like that. Data will go like that. For that question, your question is quite valid. That, but here the word is highly correlated. I don't mean maybe it can be negative, it can be positive. I'm not saying, for example, if I say uh, uh, if I say negatively correlated, negatively highly correlated, but here highly correlated means positive. But your question is valid. I think for linear regression, normally on the linear equation, it means if one thing is increasing, other thing is also increasing. You are very much true. So I will check and then I will answer about this statement. I will check because it can that this data is just a copy paste from some source. So I have to read it first and then I can answer you finally. Otherwise, your question is valid. For linear regression, normally one variable is dependent on another, okay? One variable is dependent on another. If one has, it depends actually. For example, if I draw some picture here with the temperature and the elevation, elevation means height, okay? And if I have something like that here, if I say, okay, if height is 0, temperature is high, huh? And if height is increasing, temperature is what? Decreasing. Height. So before this, I will draw this line afterward. Okay. If I will say this is elevation and this is temperature. So if elevation is here and temperature elevation is there and temperature is maybe highest. Similarly, if elevation is further increased and then temperature is what? But this is not true always, okay? In on the earth. On the earth. Normally it is okay. But this is elevation increased. And in this way, you can draw something like that. You can draw something like that. You can draw something like that. And in this way, okay, you can you can take your line like that or that. That is also something decreasing, huh? Not increasing, but decreasing. Or so here in these examples, one variable is dependent on another. That is very much true. And his question is valid. I will answer after checking it. I don't want to say something wrong, okay? So, but we can understand that we have to find these correlations. We have to find these correlations because we don't know that our model has needed this correlation or not. Because at the end of the first CLO, I showed you some diagram that if is your data has correlated or redundant, answer is yes, you have to go this, and answer is no, you have to do this. So there was a picture there. There was a picture there. So you have to find this correlation. It is necessary for your model. And what is the requirement of your model? It depends on that one. So now moving next, huh? So reviewing correlation between the attributes. So these are the same things: import, read, PIMA, headings, and here we are reading and we read on the data. And then okay, set option. Actually, these are also again the same thing. Set options mean this output, okay? Setting output, okay? Display width 100 means up to this, and then set option display precision 2. So this is these two digits, huh? And then correlations, data, this data, dot core for correlation. Method what? Pearson. And there may be some other methods available. So that's why we have an option for this. You can find that what are the different methods available. Huh? One is the most common is Pearson coefficient method for finding the correlation. So this method, so from that pandas library, it will automatically apply this Pearson method on your data. It will find the correlations and it will put the values, all those values here in this correlation now, which is an object now. And now here we are printing that correlation. And when this statement will execute, you will have the data like that. Okay, pregnancy plus all columns and pregnancy plus press all columns. So it is like a confusion matrix, huh? So same headings here row wise and same headings here row wise and column wise. Okay, and then we are saying pregnancy into pregnancy. Is there any correlation? Correlation value is 1.
Same feature.
And pregnancy with the plus, but correlation value has 13. Pregnancy with the press, correlation value has 4.14. And you know 1 mean high correlation, -1 means no correlation, 0 means 0 means no correlation. and -1 mean negative correlation. Similarly, pregnancy with the skin. This column with that. This is negative, huh? Something negative value. And similarly, so this is high pregnancy with pregnancy. Okay, in the diagonal you have high values, but that it doesn't mean because it is with the itself, huh? It is with the itself. We don't need these. This is the column with itself. So the other values has the importance, huh? Not this diagonal. So okay, 1 3 1 4 1 5 age. So age with pregnancy, it is something 50-50, huh? So and this class, okay, that is not. So is there any something high correlation and negative values? So this point 4, okay, but not 1, huh? Still far from the 1. Okay, we don't have here. This is point negative, but very close to you can say 0, huh? -1. So if 5 are higher, I am searching 5 are higher, point 0.5 are higher, positive or negative, huh? So so this is the same repetition, huh? Repeated here. Either you, because we know from our previous knowledge that these, either I can understand these values under this diagonal or above the diagonal. These would be the same, huh? And similarly, I can go on. Maybe these one, but only I have found only pregnancy and age, which is 50-50, something like that. But still, so this data set, there is not too much correlation, huh? There is not too much correlation between the columns. Now, I will start how much? Okay. The time is 11, but this is the last slide. Okay. So let's do it, huh? Just requesting you, just for 2-3 minutes. Okay, I will start next.
Are you uploading the
Yes, uploading.